All right, next up, our presenter is an 18-year-old entrepreneur who's of Syntex Medical, who's developing the next generation of biosensors to non-invasively test glucose levels. He's also been working with Mount Sinai to make those biosensors into a ring. So please welcome Ben Nashman.
Where's the? Oh, here. Okay. The human body is one of the most complex and amazing systems that we know of. And I like to think of it kind of like a machine. But like any machine, things can go wrong. For example, we can get injured. We can suffer some trauma. We can also develop diseases without even knowing that they're there at all. And to deal with these problems, our bodies develop some pretty ingenious systems. For example, whenever we have a problem in our body, we receive some sort of stimulus from it. And that stimulus is usually at the chemical level, and it leads to a real physiological reaction of our body. This could be as simple as feeling tired, so we want to go to sleep, or becoming infected with a pathogen, so our immune system responds. Now, over the past 100 years or so, we've also added medical data to this. And by medical data, I'm talking about things like medical imaging, blood tests, things where we get more information of our body, and we can generate more artificial responses. So things like vaccines, or helping our bodies heal at a faster rate. But there's a pretty fundamental issue with this entire system. And that's the only time we ever respond to a problem is when it's already there. It's not like we ever go and try to prevent the problem from happening in the first place. All the tools we have are really good at dealing with these problems, but when it comes to predicting them accurately and preventing them, we really just scratch our heads. And the main reason for that is we just don't have enough data about our bodies. We just don't know enough about ourselves at the molecular level to really understand what's going on. So we can't really predict things accurately. To help explain this, I want you to imagine a car. But this isn't any car. Imagine a car where you had no sensors whatsoever. So you didn't know things like the tire pressure, whether the doors were closed, what the level of your fuel is. So would you be able to tell whether something was going to go wrong before it did? Probably not. You'd probably just run out of fuel. Now, it seems a bit extreme, but I think this is a really good analogy for how our bodies are kind of situated in this medical system. We're literally waiting for problems to develop to go and try to treat them. So when I first came across this, it really struck me as troubling because it seems as though we're honestly just waiting for something to go wrong. But a lot of this changed when I came across the world of biosensors. Now, what biosensors are kind of like sensors on a car, except they're for a human. They're for a human. So we can get a lot of data about our bodies and generate a lot of predicting power using these biosensors. Now, the way they work at a very high level is if we want to get data about something in our body, we can't just look at it and say, there it is. Our body speaks in the language of chemistry, and we're not that great at understanding it. So what we need to do is translate those biological signals into something that we can understand, which are electrical signals. And that's what a biosensor does. Then using those electrical signals, we can detect and quantify what those biological signals were telling us. There's a lot of different types of biosensors, but obviously I don't want to go through all of them one by one. We can divide them into two main classes. The first are chemical biosensors. Now, these are things that interact with these biomolecules at the chemical level. And honestly, a lot of the times, we really just take other biomolecules like proteins and enzymes and modify them in some way to suit a specific purpose that we have. Now, the ones you see here are some of the more commonly used ones. For example, in enzyme-based biosensors, we see how fast an enzyme, or a modified enzyme, will interact with a certain biomolecule. Now, what chemical biosensors are really good at is they're really specific towards a specific reaction. So we can take a really complicated mixture, like someone's blood or someone's urine, which has thousands of different molecules in it. We can just pick out one or two signals. The other main class of biosensors are physical biosensors. Now, these are the ones that get me really excited because I think they honestly have a lot more potential. Now, what physical biosensors are doing is instead of chemically interacting with these biomolecules, they take advantage of the physical properties that they have. So that could be seeing how they respond to light or even ultrasonic waves. Now, you're probably wondering, why haven't we seen any biosensors come up? Why are these not more of a common thing? And the answer is that they just haven't really been practical until the last few years. And that's because we just haven't had good enough technology to create them on a mass scale. But that all changed when people started working with things called microfluidics. And microfluidics technologies are basically ways of manipulating extremely small volumes of liquids. And when I mean extremely small, I'm talking about very small. So bear with me in this. Consider that a drop of water is around 50 microliters. Now, most microfluidics technologies work with liquids on the range of around 1 microliter, so 50 times smaller than a drop of water, all the way down to a femtoliter, or about 1 billion times smaller than a drop of water. Now, this is really efficient for trying to interact with these liquids. And when we combine these microfluidics technologies with different biosensors, we end up with something like this, a lab on a chip. Now, this might be something that some of you have heard, but I don't think you can stress enough the importance of this. What a lab on a chip is you can imagine dozens or hundreds of biosensors integrated on a single chip that has the same analytical power as an entire medical laboratory. So this is literally an entire lab of staff and equipment all on a single chip. You could literally run an entire blood test using less than a single drop of blood. When I was exploring this field more and more, it seemed like there were a lot of crazy and unreal developments, honestly, that were coming out through all these different technologies. But what I always wondered was, is there a way to do this on the human body itself? It seemed that all these different biosensors require us to take out some sort of sample. But can we do this in vivo, or just using the human body? Well, there's actually been a lot of amazing developments in this area too. For example, this is a glucose monitor that's come out recently. It's basically a needle that you insert into your skin and you leave it on there for several days. And it's constantly monitoring glucose levels using that needle. This is actually a completely ingestible biosensor. So what you're seeing here is a biosensor shrunk down to around the size of a pill. And with a single ingestion of this, you can replace an entire colonoscopy. So it's some pretty crazy technology. Some of the more exotic biosensors that we've been seeing recently are things like this. This is a tattoo with a special type of ink that reacts with different molecules in fluids surrounding our skin. And depending on how hydrated we are or the pH of our blood, this tattoo actually changes colors to tell you what's going on. But for me, I was always really interested in knowing what's in someone's blood. And the reason for that is, if you go to get a blood test, you get a really good picture of everything in someone's body. With a single blood test, you can know how literally every organ is functioning, how someone's metabolism is working. But when I looked around, there didn't seem to be any biosensors dedicated toward blood monitoring in vivo. So there were no biosensors that you could just wear to tell what was in your blood. And so it seems like we're just losing a lot of data with that. Now, to solve this problem, I started a company called Synex Medical. And what we're doing at Synex Medical is we're developing technology that's going to allow users to monitor what's in their blood in vivo. So this is blood monitoring technology that you would literally be able to wear and know what's in your blood. Now, to do that, we're taking advantage of the different magnetic properties of a lot of the different chemicals in someone's blood. Now, because this is a magnetic technology, it allows for completely non-invasive measurements, meaning no needles and no finger pricks, nothing. So the blood literally stays in your blood vessel, and we can perform nearly an entire blood test on it. Now, what I'm working towards is miniaturizing this technology into something wearable, like the size of a ring. So when a user would wear this, they'd be able to constantly monitor all the different metabolites in their blood without any needles again. And what this essentially leads to is something that I like to call optimization of life. So we can literally optimize all the different parameters of someone's life quantitatively. So we have an actual measurement of how someone should be living their life in the most healthy and optimal way. If someone has a disease, for example, diabetes, cancer, there's a lot of really relevant biomolecules to that disease. And the prognosis of someone living with that disease usually depends on how they're treating their body. And those biomolecules can tell us a lot about how they need to treat their body. In diabetes, you need to do constant glucose monitoring. With cancers, there's a lot of different amino acids that are relevant. Now, there are hundreds or thousands of other diseases, and I've listed just a few here, that all need, that can all benefit from constant metabolite monitoring. For general health, we can tell how much someone should be taking of a certain supplement or what medication they should be taking by seeing the results of changes in their blood. For example, if you go to get a blood test and say you're low on vitamin D, your doctor's going to recommend that you take a supplement. But how do you know that it's working? How do you know that you're getting enough vitamin D after that? How do you know that your vitamin D in your blood is actually responding to that properly? So you'd be able to quantitatively determine how much vitamin D you should be taking, and then watching how that changes in your blood over time. There's also other things like actually determining how hydrated you are. When you need to be drinking water. Evan recommends you get around 8 glasses of water a day, but is there a way to actually determine when you need a drink? Or optimizing if someone eats. If someone's showing a low amount of amino acids, it probably signals that they need to be eating more of a protein-based diet. In terms of fitness, we could actually determine whether a workout was effective or not. And I think this is pretty interesting, just because of probably the big market in fitness monitors. Now, when someone works out or when someone engages in some sort of physical activity, their muscles release lactic acid, which is turned into lactate in someone's blood. So you could quantitatively determine whether a workout was effective or not. You could also look over time to see how the oxygen levels in your blood respond, to see how your general health is responding to that. Now, with all this data, it leads to something, it leads to basically a way to predict and prevent diseases at a much more accurate rate than what we're doing right now. Imagine thousands of people monitoring their metabolites in their blood constantly for about a year. The amount of data we get from that is incredible. And using all that data, we'll be able to predict some amazing things about developing diseases and ways to prevent those diseases from developing in the first place. So for me, the most exciting part of this is looking at all this data. Imagine the machine learning we could do with that. Imagine the patterns we can find if we find a group of people here that are developing cancers, but these people are having a bit more, for example, acetone in their blood, so they're not developing this cancer. There's a lot of potential just for looking at the data in this. Now, we can obviously see that we need a lot of improvement to this medical system. And I think the future is going to be in biosensors. And I'm excited to be a part of that with Synex Medical. So, thank you.
Good stuff, man. So, does anybody have any questions for Ben besides how long before we start working for him? So maybe in the front, Amanda.
Hello, that was an amazing presentation. Really excited about it. Are you looking for any test subjects that would will?
Well, right now, honestly, testing, especially in the medical field, there's a lot of hurdles to get through. So I forget who mentioned before, but I'm actually working out at Mount Sinai Hospital now. And so I'm getting a lot of, blood samples from there. But in the future, when we're running clinical trials, we'll probably post something.
One more?
Hi, I just have a question. Thank you for the presentation. It sounds like you're doing really interesting work, but with this work,
So I guess I didn't really explain the kind of overview of how this would work for a user. Essentially, what it would be is you'd have the device, and it would pair with something like a companion app on someone's phone, and of course, that data would be encrypted when you transfer it across. In terms of actually analyzing that data and what we're doing with it, I mean, honestly, it seems a little down the road from where we are right now, but I'm sure that whenever we use someone's data, we're going to need consent and never share it with any third parties or anything like that. Sure. Yeah, yeah. I mean, they're important things to think about, and I think we should do a lot more probably down the road to look at that.